Hey there, everybody. Thank you so much for coming. I can't believe this packed house. I really appreciate everybody joining us today and everyone who's watching remotely. Thank you to JetBrains for giving me an opportunity to speak to you guys today. My name is Andy Goldberg. I am based out of Las Vegas, Nevada, USA. I am a solutions consultant, and as you might imagine, many of my clients are in the casino and hospitality industries. So I use that term solutions consultant because there's no way to just sort of specify one specific specialty, right? In this industry that uses a lot of, everything is based on technology, but a lot of that technology is pretty old and legacy stuff and not, up to the current standard. So you really have to be able to dip your toe in like every pool and be able to put lots of different things together. So for example, on a recent project, I had to work with an abandoned, poorly documented XML-based API to build the solution to communicate with one of the gaming systems. And for that, fortunately, we have Kotlin X serialization, which has an XML component to it. That was a lifesaver. Another project I recently worked on was to evaluate a new proposed blackjack game, a variant of standard blackjack, and we had to run billions and billions of hands in order to make sure that the game was not beatable by card counters or by some strategy, player strategy that we hadn't thought of. So again, Kotlin to the rescue with coroutines. We were able to distribute the iterations over 32 core, 64 core cloud server, and everything worked great. But today I'm going to talk about Kotlin dataframe, right? So we are going to have some live coding a little bit later. I know some people, it's sort of like Formula One, some people like to tune in for the artistry and the skill. Other people like to tune in to see somebody crash and burn. So don't know which way it's going to go. I'm hoping for the best, but hey, we'll see. So what's a data frame, right? A lot of coders, programmers, sort of like there's this like invisible wall. They don't really like to broach it and say like data, that's somebody else's problem. We have database admins for that. We have data engineers for that. I don't really get into that area, right? So sometimes a new term might be like intimidating. But in this case, it shouldn't be at all because a data frame is essentially a data table. It's very simple. Anytime you have a 2D representation of data with rows and columns, that's a data frame, right? So yeah, once you realize that, then you realize they're all over the place, right? You see them obviously in databases, Excel spreadsheets, CSV files, HTML tables, and business intelligence reports, and they're everywhere, right? So any programming language, any ecosystem that wants to be able to work with data and help their programmers work with data needs a library similar to this to help you reshape, transform, do all these functions that we're going to talk about in a minute. So data frame is not a Kotlin thing. It's been around for a long time. The R language basically has had data frame since its origin. Pandas in Python is probably the most popular data transformation analysis library in the world. It's super popular. That's why Python is sort of the gold standard right now of data analysis, because specifically of pandas. The Julia language has basically leveraged data frames from the beginning. You see it in Spark. So just doing a little research, the S language, which was the precursor to the open source R language, introduced data frames in 1991. So it has a long history, and now it's come into the Kotlin world. So, immediately you might think to yourselves, well, those previous implementations, right, they're in languages that I might not want to use every day, right? So for the first thing, they're all dynamic languages, right? The other thing is because they've been around for a long time, they don't all have the greatest syntax. Some of them were developed 20 or more years ago. So to be fair, a lot of these have evolved significantly. They're a lot easier to use if you used R in 2010, if you picked up pandas in 2014 and now came back to them today. They certainly have improved. Still, you have blog posts like Wes McKinney. He is the author, the original author of the pandas project. And so about 2017, he wrote this blog post saying the 10 things that I hate about pandas. So when most of that stuff was like under the hood stuff, memory management, how the columns were represented. But still, when the author of a library, an extremely popular library, comes out and says 10 things I hate about my own creation, it gets a little bit of buzz, right? So Kotlin has the advantage of seeing what works and what doesn't work and building something new and taking advantage of the features of the language and the best practices, right? So one of the really cool things is that every method in the dataframe library is fully chainable, right? So I like to write most of my Kotlin code the same way in sort of a functional manner where like multiple methods all chain together, and dataframe allows you to continue to do that. No method will just return like a series or a single value, and then now you're stuck creating like multiple intermediate variables. Obviously, you have strong typing, okay? So every column, there's no question about what data type a certain column is going to be. It's definitely going to be an int. It's not going to be a string that happens to look like an integer, right? Nullable, all that. So the strong typing is really important. Having multiple access APIs is also very cool. So it's kind of funny because it was sort of talked about this morning in the keynote. If you are in your code, if you have a class, if you have an interface that you know you're going to use as part of your data frame, you can just annotate that with a data schema annotation, and the compiler will immediately recognize that when it gets to that point, we can just refer to these specific columns the same way as part of the class with simple dot notation, no boilerplate, and it'll know what data type that column is supposed to be. So there's other times when you don't have a whole class or interface that you have annotated, but you know that like there's going to be this single column that I'm going to refer to a number of times. So you can just create a variable out of that. Val, your column name by column string type. And then that column is easily accessible, again, without any like quotes around it. And then, of course, if you create a new column on the fly as the result of a calculation or something, then, of course, you can refer to it with quotes. That's like the most dangerous because you can make a spelling mistake, a capitalization mistake, something like that, and you have to redefine the data type. But still, that's still really common and very useful to be able to do. But being able to access your data types and your columns all three ways comes in super handy. So the fact that your columns can also contain classes is great because then you can use the methods that you've defined on those classes to further do your data transformations. Again, super useful. The fact that you're basically always using native Kotlin code, the interop with collections, and being able to do all this in Jupyter notebooks, which we'll do in a minute, all of that is really great, right? So we know what a data frame is. We know that there's this thing called a data frame library. So what's the whole point? What can we actually do with this, right? So here's a list of like the most common functions. Right, almost any kind of data transformation that you might think of doing is possible, right? And a lot of times people think of the data frame library, or if they're thinking about R or pandas, all this together, they're thinking like it's hardcore data analysis, right? That's the only people who would be using this on a regular basis. But that's not really true at all, right? It's most of the time a transformation. You have data that's in some source database or a file, something like that, or multiple sources, and you need to do some transformations, joining, whatever, not because you're trying to do some analysis on it, but you just need to send it to some other destination, an API, a file, another database, something like that. So this is sort of the intermediate step that gets you there, that lets you reshape the data and get it to your destination, right? So a bunch of those functions, a bunch of those things you'd want to do, right? Obviously, there's tons of tools out there that already allow you to do these things. And certainly, no single library is going to put Excel or Tableau out of business. But those are manual programs, right? You can't like embed them in code or something, unless you want to write VBA in Excel, and none of us want to do that. SQL obviously is super popular for interacting with databases, but SQL has lots of problems itself, right? No source control, no hierarchies of classes or anything. It's very, it can get very wordy. And not everything is in a database to begin with, right? If you have CSV files or pulling data from an API, something like that. So SQL's not always available to you. ETL tools, they're also used for like getting data from some source into some destination, but again, it might not be the programming language that you want to work with, or they might not have all the functionality that you already that you need to implement. And then you have Kotlin collections, right? So just a simple list of your classes or set, you can obviously sort, you can filter, you can map to something else, but there's also what you can't do, for example, is add a new property like on the fly, whereas in a data frame, you can take 2 columns and calculate them together and create a new column, or do any kind of data transformation. So there's a lot of things you can do with the data frame that you can't do with the collections, although the interop between them is important and very easy to do, right? So when I first got a hold of the data frame library, you know, it's still new, still in beta mode, but one of the first things I noticed was it interops with these other data files, but not directly to a database, right? So at first I thought, well, if it doesn't actually let me execute a query and pull back data from my database, then it must not really be developed very much. That everything else must be missing as well, right? But soon I realized, like, hey, that's not a problem at all, because we already have on the Kotlin platform, Java platform, we still have plenty of tools that allow us to interact with our databases, right? So the separation of concerns is like a positive thing, right? Let the data frame library focus on the data transformations. Let whatever ORM or Juke, if you use that, which is really a great library, let the database tools interact with the database. Let the data frame library deal with the data. So not having direct, the ability to run a SQL statement is like not a problem. No SQL injection errors, stuff like that. Yeah, so the use case I'm going to talk about today is basically something that a client needed. They had a very manual, very Excel-driven process. It was slow. It wasn't flexible. Their marketing team had tons of ideas that they wanted to implement, but they weren't able to do it because they just didn't have any systems in place to do that. So the first thing when I got there was to sort of like, real quick, like put together a SQL-based pipeline, which sort of worked, but it was awkward. This is sort of a quick example of what like a SQL setup is going to look like, right? Like I said, there's no source control. You have a totally flat hierarchy. It's hard to figure out what view references a different view or what tables. It's a real mess. My source control essentially is like V1, V2 of stuff. It worked, but it was bad, and it was hard to maintain, and you still had to like run it manually. And at the end of the day, you still just got results in a query window, not as part of a larger program. So I knew I wanted to do something better, and I knew that I was programming everything else in Kotlin. So of course, I want to use the Kotlin data frame library, which at the time, like I said, was a little bit dicey because it was still early. I didn't know what had been implemented or what hadn't, but it was basically just experimenting, trying it out, seeing if I liked the syntax, seeing if the functionality was there, and for the most part, like everything I wanted to do, I could do it. So It ended up working out great. A bunch of the advantages were pretty obvious like early on. So just to give you an idea, like the scope, some larger enterprises in this world would use like these big enterprise-ish tools, right? We're basically creating the same thing all in code in Kotlin, right? So instead of spending, hundreds of thousands of dollars, millions of dollars on these IBM and Teradata tool, I don't think IBM owns that anymore, but yeah, these tools that are like big legacy, we're doing it like lean and quick and fast. So the reason this is a difficult problem is there's a lot on this slide, but to create a casino gaming offer to a specific person, right? A specific person at a specific time, at a specific location, and make sure they get the specific amount that you want. There's a ton of individualization and customization that goes into that. Lots of systems that need to be involved to deliver that particular offer to the player. Lots of like adjustments based on if you're doing testing, if a player has a relationship with a host, things like that. There's a lot of things that go on in the casino world that make this complicated. So this is not a casino only type thing, right? Any organization, any company that wants to send a customized marketing message to their customer base is going to have some challenges in making sure they're getting the right message out, right? I drink a lot of Coca-Cola personally. So if the market is going to send me emails or notifications that Coca-Cola's on sale, that's great. I'm going to go right to the store and load up. If they somehow group me as just a sort of generic soda drinker, and they're sending me notices when Pepsi's on sale or some other drink is on sale, then I'm going to like say this, I don't care about that, and like I'm going to send it to spam real quick. Same even like with JetBrains, right? If they're sending you the like notice like, hey, it's time to resubscribe, it's time to renew your subscription. In the keynote earlier, they asked like how many people here are Android developers, and a lot of people raised their hand, but also a lot of people didn't raise their hand, right? So if they just sent out a note to everybody that said, make sure you resubscribe to IntelliJ because the best IDE for Android development, again, that's not a message that necessarily resonates with everybody, right? And if the currency is in just something generic, euros, dollars, it's not going to necessarily resonate with every customer out there. So it's very important to make sure your messages are to the right players or to the right people. Casinos just sort of, they have a lot of data on their players, and they're aggressive in terms of sending them offers to bring them back into the fold. So, by the way, JetBrains, I'm going to resubscribe no matter what, so it's okay. So you might be familiar with this meme. I sort of flipped it though, right? So it's time to build the offers. Well, if my only tools are SQL and Excel, then I have a little bit of a problem, right? Then I'm concerned. But now we have Kotlin dataframe. Yes, we're all good, baby. So, all right, let's do a little live coding. Yeah, all right. Let's get into this. Okay, so yeah, so we start out here. So this is the Jupyter notebook, in case you're not familiar with it. It was really cool to hear this morning that they're going to have these native Kotlin notebooks. I can't wait. That sounds really amazing. But yeah, the Kotlin kernel for Jupyter is itself really sophisticated and pretty awesome. So we're going to start here with 6 different data sources and basically get a look at the first data frame. So just to give you an idea of what we're doing here, this is obviously a simplification of a more sophisticated setup, but we have 2 geographic segments. The Las Vegas group, they're the people who live within 15, 20 minutes of our casino and can be there, they come like on day trips. And then you have the California segment, which is 4 to 7 hour drive away, or a little bit of a plane ride. So they're going to be less frequent, but hopefully stay quite a bit longer and spend more per visit. And so we have these min-max values where each player will get like bucketed in based on their daily anticipated spend at the casino. And then each tier has like an ID number. And so as you see here, we start out with 16. That's what we're going to work with. And we are basically, our goal is to create customized messages. We're going to send like a mailer out. We're going to create a file that we can send to our printer, and they can create like a mailer and send it out to all our customers, right? So we have this marketing copy here, and you'll notice like a bunch of like double tilde, double at sign, double asterisk. Those are going to be, that's just a simple like crude search and replace. So a little bit later, when we have the numbers to fill in, we will replace all those signs with the actual values specific to that tier and that customer. So you notice here we have tier min and max, whereas up here we have specific tiers. So we're going to need to match them up. Oh, shoot. Right. So this is where the kernel and the data frame work together. It's very cool. So in this code block here, you'll see that the first thing I'm doing is defining a new data frame. And you'll notice that I'm going to create a new column called tier, and that's what I'm going to use to match up with the earlier data frame. And I have quotes around it because I'm creating it right now on the fly. And so I reference it a couple times with quotes. Down here, though, I'm trying to reference it without quotes, as if it's already known. And it's already telling me, like, that's not going to work. That's going to be an error. So what's cool, though, is if I run this, yeah, I'm going to get an error, right? But what I can do is if I split this, split the cell, and run the top part, so now the kernel immediately under the hood reevaluates all your live data frames. And just by running that one code block, now the tier column is available to me without any quotes, and it's a known data type. So I can reference it in more code, and this is where the Kotlin kernel like comes in handy. Oh wait, splitting it, running it. Yeah, okay. So the kernel is actually helping me by, it knows the functions I might want to run, and it knows the names of my columns, so it actually starts to prompt me, right? So placement and tier are like available to me. So when I'm building these pipelines and using the Jupyter kernel to do it, I have this like automatic iteration, and everything is like prompting me with all my columns, with everything I need to know, with all the functions I can run. So it's basically like helping me out. And again, every single code block I run, it reevaluates everything, and all the columns that you just created one block earlier are now totally available to you as like native objects. So this is the new data frame that I created. Hopefully you guys can focus more on the Kotlin stuff, less on like the actual marketing stuff. But right here, conceptually it's a little tricky, but like we're pivoting this and creating individual column for each of these placements, all the little marketing copy that we're going to include, right? So pivoting basically turns this by 90 degrees. So when we do that, our new data frame has each of those like wordings in its own column. And I'm back to having just 16 rows, one for each tier, right? So the next thing we're going to do is combine them with the offer amounts. So here we've defined based on some casino players prefer slot machines, others prefer table games, blackjack, roulette, stuff like that. So depending on the game preference, that's going to influence the amount of like free money we're going to hand them ahead of time. So is there a question back there? Sorry. I can, yes. Sorry about that. I hope that helps, yeah. So in this next block here, what we're doing is, I was talking a little bit about the APIs earlier, right? So here I'm defining a column that I'm going to reference a number of times. So I just create a new val with the column as a string, and then you see I'm accessing gamepref here, so I don't have to use quotes, and so the compiler knows what the data type is supposed to be. And so when I do this, I'm creating a new data frame. Again, this had this explode function. So for each row, there's slot players, there's table games players. The explode basically creates one row per element of the list. So I've now got 32 rows total, 16 times 2. So you see my tier 1001 has 2 game preferences, and the gaming amount column is based from above based on the appropriate value that matches the game preference here. Later, when we merge with the players themselves, we're going to merge on what tier they're in and what their game preference is. So that's important to have. This block here joins all the data frames that we created already and then does that string replacement. Now that we have the values, so this looks kind of complicated, but if you look, most of this is just string replacements. And again, you're using native Kotlin to do that. But it accesses the values in the columns, for example, gaming amount times gaming frequency. So those Las Vegas players who are high frequency players are going to get 10 different gaming periods over the course of the month, right? So June with 30 days will have 10 3-day periods in which they can redeem their offer. And so we're just doing the simple calculations here and assigning that to new columns. And then you can see now that that sort of generic marketing copy is filled in with individual values. You have 10 June offers worth $3,400 or $2,240, and that's made up of a certain amount of gaming dollars and dining dollars as well. We can describe our data frames here, which is a little more useful when you are doing more statistical analysis and you want to get standard deviation, min, max, all that. But even here, we're doing more categorical stuff, but it's good to know that like offer month, we just have one unique value because we're dealing with, say, June of 2023. If somehow some July or August got in there and we had more than one unique value, we'd know we had a problem. So I've been talking about 10 different periods, the 4 different periods for dining offers, and then that California group, they just get 2 offers for everything, right? So this is the data frame that represents all the individual calendars. Going from these ISO-based dates to a human readable string is a little bit tricky, depending on if you flow into the next month, the next year. So we're going to create a class and some functions to help us out with that. That's what this block does. We create this data class offer calendar. So by creating those classes, now we can take our data frame, and you can see right here we have this very simple to list of offer calendar, and that's the interop between the data frame and Kotlin collections. It's super easy. You don't have to like redefine anything. It knows what the properties of are for your calendar class, and it knows the columns in the data frame, and it knows that they match, and therefore super easy to go from data frame to list or other way also. Okay, this block is a little more complicated. There's a lot of stuff here, but basically we're taking the list of the calendar classes that we created. And first we're going to, on the top here, we're going to filter based on, is this the Las Vegas group or is this the California group, right? That's the first add method. Then we have a second add method where we're going to add 3 new columns based on what type of offer is this calendar representing. Is it a hotel, a gaming, dining? So we have 2 filters basically in a row. And then the next thing we're going to do is each of those 3 columns now contains a list of calendar classes, calendar objects. So we're going to split each of them so that each new column now just creates 1 element each. We're basically going from a list to a series of columns. And then the last thing we're going to do is, again, we're going to convert from the class to a human readable representation of the date range. So there is a lot going on here. But again, it's all like one concept, right? You're just trying to represent to the players the dates in which their offers are available. So you've seen these columns earlier. Let's go to the right and see what we just created. And yeah. So yeah, we have like a hotel 1 and 2, it's cut off. You have gaming 1 through 10, and like 4 dining. And you can see now we just have date representations. I cheated a little bit. That last one, I had spill into July. So this is what I was saying about like the human readable representations, a little bit tricky, and that's the importance of creating a class with dedicated methods for doing this as opposed to trying to do it like on the fly. Because here, this last one goes June 23 to July 3rd. It's important to get that July in there. And you also notice the California group that we defined is only having 2 offers for each, right? There's no problem here. There's no error. There's no null value. We defined like, hey, if you don't have something for this particular column, just produce an empty string. That's a lot better than sending to your printer something with a whole bunch of null values and then getting a call on the phone. What am I supposed to do when it says null in it, right? So the last thing here is we're just going to combine this now with the players, right? So basically when you are creating a mail file or working with your email provider, whether that is SendGrid or Postmark or any of these, they want, you know, 1 individual row per customer, right? So the idea of like, say, telling them, hey, just combine the player with the right tier. No, you can't do that. You have to create that for them. So as you see here, we have the name, we have the address, and then as we scroll, all the marketing copy, all the marketing messages that we spend all the time creating is all connected to each individual player. So obviously there's a lot of repetition here, but that's the goal that we were seeking to achieve in the first place. And then the last step would just be write these out to CSV files, 1 for the mail, filter it on people with valid email addresses, and write that out to an email file. And yeah, that's basically this like pipeline, right? So yeah, so thanks for sticking with me and like walking through all that. Obviously, like the end result isn't to do all of this stuff in Jupyter, but basically you use Jupyter, you use a dataframe library to like iterate through to make sure your pipeline works from end to end, from data source to whatever the output is, or again, sending it perhaps to these email APIs, your gaming systems, whatever it is. And you incorporate that as part of your Kotlin code, right? So you build a web front end or some UI where your employees can, you know, click a button or fill out some form that says, hey, I want to perform the June, you know, mailer preparation for this particular geo group, right? You build a API with something like HTTP 4K or KTOR, and then you take all this code that you just built, wrap it in a class, a few methods, however you want to organize it, and now you have like the whole pipeline from single button click to your final destination, whatever that might be, or multiple destinations, and it all just works beautifully. And that's what we implemented in this particular case. So I've been talking a lot of good things about dataframe. Is it absolutely perfect? It's not. It has a couple of issues. Not every function that you hope for is available. Obviously, it is a beta product still. I think it's 0.9.1 is the latest release. The one biggest drawback, I would say, would be speed, right? And that's not something that the developers did wrong, but the JVM currently does not have a vector API, right? So the reason that pandas and R are so fast, which makes them popular, is because they can do vector math. So they can, if you have billions of rows, they can do the calculations all at once, as opposed to iterating through a list, right? So hopefully the JVM will have that vector API possibly in the next long-term release, 21, this fall. And if it is, I feel confident that the Kotlin developers will incorporate that into future versions. Yeah, pandas also has stuff built, it's underneath in native C, and that helps out. I wanted to do some benchmarks, but when I did start to do them, it was clear, the Kotlin data frame can't keep up right now, right? You also get some memory errors and stuff like that. So if you are doing hardcore data analysis, if you're dealing with sort of cloud scale, billions of rows, multi-gigabyte files, stuff like that, it might be a little bit of an issue. But for sort of most business processes, it's totally workable, totally fine, absolutely great. So as far as the future, what I'd like to see going forward would be, again, to expand the API. That's its best feature. Little boilerplate, easy syntax, very direct of what you want to do. Yeah, taking advantage of any kind of vector APIs that are released, and then interop with other sort of projects that are gaining momentum. We already got Apache Arrow in the last 0.9.1 release, and maybe DuckDB, maybe Parquet in future releases. And then the other thing is just marketing, right? More people that know about it, more people that try it out. That's how the ecosystem builds, right? So I want to thank everybody for attending today. I really appreciate your time and attention. I want to thank JetBrains for the opportunity to speak about dataframe. It's just been terrific to work with on a daily basis, and I really enjoy it. If I have one more second to just acknowledge one person, his name is Ian Brandt. He runs the San Diego Kotlin user group. When all these user groups went virtual, attendance went way down, and we have some months with just a few people. He could easily have just given it up, but he hasn't. He persists every single month, coming up with something new to talk about, new news, new projects. And for me, that's a big help, feeling like a part of the community and stuff. So he's a great advocate for this language. So JetBrains, send some love to San Diego. So thanks again. I really appreciate all your guys' attendance and attention. And yeah, great. Go ahead. Happy Kotlin.